Before we start, let's talk about the parts of a compass. No matter which compass you are using, I'm going to use the term eye to describe the same part. This is where the center of your circle will be placed. Now let's look at bisecting an angle or line segment and constructing perpendicular lines. Some of the keywords you're going to see are bisect, perpendicular, and midpoint. This can be performed on line segments, lines, or on angles. To start, we need two equidistant points. We can make these points with a circle by putting the eye on a given point or vertex. In a line segment, we're already given the 2 points we're going to use. But with our other 3 shapes, we're going to place the eye of our compass on the given point. With angles, the given point will always be the vertex. Now, we're going to draw an arc with our compass and label the intersection as our 2 points. If our line is too short, we can make it longer. Make sure you grab a straight edge. And these 2 points will be our intersection. We can draw the same arc on our angle and our 2 points of intersection. For step 2, we're going to draw a semicircle around one of our points. Be sure that the radius of your circle goes past the apparent midpoint. So in our first shape, we made our compass a little bit longer than where we thought the midpoint was, and we're going to make an arc. Step 3 is to draw a congruent semicircle around the other point. So again, my compass with the same radius, and I'm going to draw a semicircle through the middle again. So in all of these, we're going to choose a radius that is slightly past the midpoint and draw an arc. Then we're going to slide our compass onto the other endpoint and make another arc. And for all of these, we are now on step 4. We're going to draw a line through where the congruent circles intersect. Okay, so we can see where the 2 circles touch. We can draw a line. Where our 2 arcs touch, we'll draw a line. And where our 2, for this one actually, a little bit different, we can go from the vertex through our point of intersection. Keep in mind, if you needed to inscribe a square, you will draw a diameter, just like the line segment on the left, and bisect it like you did the line segment on the left. Then you will connect the 4 points on the circle. Let's look at copying a segment, copying an angle, and parallel lines now. For this one, you're going to look for the keywords congruent, copy, or parallel. You might see an angle, a line segment like we have on the left, or a line that they want you to draw a parallel line to it. Let's talk segments first. They're a little bit more straightforward. For segments, you're going to place the eye of your compass on one endpoint of the segment. Then, you're going to make your compass large enough that the other side touches the other endpoint. As you can see, my compass, my circle, is large enough that it is touching the other endpoint. Now, without changing the size of our compass, we're going to place the eye of our compass on the new point, that given point, and draw an arc. So we're going to slide our compass over, and we're going to draw an arc, and then we're going to connect our given point to that arc. Yay! We're done! We copied a segment! Now, let's talk angles and parallel lines. If you are asked for parallel lines, your first step is to make an angle by drawing a long line from the given line through the point with a ruler. We're going to be copying this angle. Now notice, if you were asked to copy an angle, you'd already be given one. Now, we're going to draw a semicircle on the vertex of the angle and a congruent circle on the given ray. So starting on our vertex, we're going to draw a semicircle. And then on our other point, with the same setting of our compass, we're going to draw another arc. Now, we're going to copy the segment that connects the points your circle made onto the new ray. All right, bear with me now. See how these 2 points of intersection hit the 2 rays of my angle? Imagine them as a segment. I want to take that segment and copy it onto my new arc, just like I copied my segment on the left. So what I'm going to do is, I'm going to take my compass and make the radius hit the other point of intersection. Then I'm going to slide my compass to the other point and make an arc by connecting our given point to that arc. We're actually going to have a congruent angle and a parallel line. Exciting, right? Kind of cool. It's really amazing how similar all these constructions are. Now we're going to be inscribing an equilateral triangle or inscribing a regular hexagon. This is Miss Atkinson's favorite construction. It's very soothing. If you ever get stressed out during the test, feel free to try inscribing an equilateral triangle. The keywords you're going to look for are inscribe, hexagon, and inside a circle. If you're given a circle, you can set the length of your compass to match the radius of that circle. Otherwise, you're going to take your compass and draw your own circle. Now, your key point, keeping the same radius. Your radius will not change for this entire construction. Keeping the same radius. Draw a semicircle through the interior of the circle, intersecting the circle at 2 points. Because now you can place the eye of your compass on one of these 2 points you made on the circle and draw another semicircle. It does not matter which point you choose. We're going to draw our semicircle. And we're going to continue to make these semicircles until all of our petals are formed. You're going to see what I mean by petals in just a moment. So our eye goes on our next point of intersection. Our eye goes on our next point of intersection. Our eye goes on our next point of intersection. And our eye goes on our final point of intersection. Notice that my flower on the right is a little lopsided. It's okay if it's just a little lopsided. Now for a hexagon, you're going to connect every single petal tip with a line. For an equilateral triangle, you're going to instead connect every other tip. So the triangle on the right, I'm connecting every other tip. And the hexagon on the left, I'm going to connect every single one. And those are all the constructions you've learned in geometry.